also limit if it's the three of these. It's also called a Bernoulli process. Now we come to this thing. Supposingly, if you want to, you can even draw with a tree diagram. That will take time. I'm giving you an example, on page 203. If you want to have x successes, here x, our random variable, is the number of heads in the coin tosses. So here the value of x can be from, we can get no heads, 1 head, 2, 3, 4 or 5. Mark this, the number of successes is not equal to the number of trials. Here, so you can see it's a discrete random variable. Now, supposingly we have a question. I want to know what is the number of outcomes of getting 2 successes out of this 5 trials. Here it's n is 5, p is 0.5. Okay, so there's a formula that is number of outcomes. I guess you all know what is a factorial. So this is how you find the number of outcomes you require. Let's say here I need 2 heads. Head. What is the number of outcomes for getting 2 heads? So here it will be 5 factorial divided by 2. Another 1 minus p would be the failure. This is the probability of getting just 2 heads in 5 trials. So we can find out the probability will be p square 1 minus p to the power q. So we derive a formula from this. Like if you have any number of trials for any other experiment and you have to find this probability of success or probability of failure, the formula is probability is equal to p to power number of successes, that is x we want, and 1 minus p, the number of failures. P to the power probability of success to the power of number of success, probability of failure to the power of number of failures. That's it. So we now come to the binomial probability distribution. Probability distribution is this probability into this outcome. So f of x, we denote it with f of x, that is so for example we have to find again the 2 successes of 5 trials. It will be this will be the probability distribution of this coin toss experiment. Now we can also plot these. It will be easier for you. The graph we can draw is the probability distribution by the number of x random variables. So you can calculate values for different x's, and you can plot this on this graph. Here like we discussed, expected value is the weighted mean. Here the expected value is n, p. N is the number of trials, p is the probability of success of any trial. And variance of x is equal to np into 1 minus k. Okay. Any more questions?
Shreya, can you explain this graph?
See, you can find out for different x values.
Yes, suppose if you take the values from this book, and can you draw what exactly this graph depicts?
See, You also have a
See,
table.
we'll get the number. We'll
Yeah.
get the number from this and we'll plot on the graph.
Yeah.
So can you tell me, like, can you explain in graph
It's a
what
pictorial
exactly it is?
representation. Obviously, a pictorial representation is easier than to check it in a table.
Exactly.
So you go for a pictorial representation of fx versus x.
So what will be the conclusion after like plotting
Well,
all
you
these
know.
values on
You
this?
know for the
Can you,
different
can,
values.
you, can you plot all these values on it?
Like for example, I haven't calculated. I'll just give you an example.
Suppose we take this example 0 to like 0.3. It is already in book.
Okay, you want me to take this one?
Yeah, 206 on page number 206.
Yeah, I know. This is the example you're talking about?
Yeah.
Okay. So now, if I give you a table for this f n versus x, is this easier to evaluate, or is that easier to evaluate?
Obviously, that would be
That no. So you, for different values of the random variable, you know what probability. This gives the probability distribution. What probability is being assigned to each and every variable. So it's just a pictorial representation to make it easier.
So what will be the conclusion after drawing this graph? What you are thinking about this? Is it showing something or not?
You can
Just showing the
see
numbers.
the probability of this for one is highest, and you know for the example given is that Martin clothes store, right?
Yeah.
So you know now the probability of each of the all the three buyers, the customers buying, is the lowest, and probability of this one buyer, one customer buying is the highest.
With the frequency distribution.
Yeah, frequency distribution. That's it.
Shreya, I have a question. I couldn't follow this n factorial upon x factorial. What do we find out from that formula?
It's just a number of outcomes. Okay, like I told you the example. Supposingly, I have to find two successes. In the means, I want what's the number of outcomes with only two heads. Successes is heads here. So I want the number of outcomes with only two heads amongst these 5 identical trials. So I have the number of trials. I need only two successes, only two heads. So this is how you do it. And then you calculate the probability. That's it. Anything else? That's the probability distribution.
Is there a difference between probability distribution and probability density function?
Probability density. Yeah, this distribution is actually assigning means different probabilities. You not for density function, you not calculate the densities here. You're just assigning the probabilities to the values of x.
I didn't follow this.
How do I